Yeah. Now let's look at a few finance-based functions which are more commonly used. Again, these are not targeted towards any finance professional or anything. These are the most regularly used kind of features and formulas which can help us in our regular investment decisions also. Let's say I deposit something for 5 years, how much will I get? Right? Or I take a loan of something, how much EMI I have to pay. So these are the kind of formulas that we are focusing on here. Right. So let me create a few queries on that same lines. Let's say if I deposit some 10,000 now for 5 years at 8.5% per annum, how much will I get at the end of the period? So if the compounding is done quarterly, how much would I get? First one is like an annual compounding. This is more like a quarterly compounding. And let's say if I borrow for some 20 lakhs at 11% per annum for 20 years, what is my EMI? Or another scenario is if my money is doubled in 10 years, what is the interest rate? So these are very common kind of applications which are used as a part of our day-to-day kind of scenarios. Or if I get, okay, if I have invested 10,000 now and I'm getting 3,000 after 1 year, 5,000 after 2 years, 4,000 after 3 years, and another 4,000 after 4 years. What is my interest rate in the process for the whole period? And in the same example, if I require 10% per annum return, is the above investment a profitable one? Right? Very common stuff. It does not require any specific finance background or anything, because most of us, even if we are not from a finance background, we would be more interested in probably doing some kind of investments in some form or the other. So we would like to check out how much will I get, or what would be the amount. So in all these kind of cases, we depend heavily on some of the finance functions. There are very few finance functions which will solve all these problems. Or to start with, there are 5 key fields of finance, and they also go as formulas also. There are 5 key fields, which is one, a PV, which is nothing but a present value, which is the money which I either deposit today or get today, pay or receive today. That is what I call as a present value. FV, which is a future value, pay or get something in future, right, as a lump sum, not not a repeated installment kind of an amount, but as a lump sum I pay or receive is one value, which is FV. Then there is an interest rate in the process, which is as the Excel term for that is rate, which is an interest rate. This is actually called as periodic interest rate. So the period could be annual, quarterly, whatever it is. It's a periodic interest rate, but we'll represent it with rate. Then we also have a term called NPER, which is more like number of periods. Could be number of years, number of months, number of quarters, whatever it is, number of periods. Then we also have PMT, which is more like in finance terms, it is called as annuity, which is more like a regular payment or receipt at regular intervals of time, right? Like your premium payment, right? Like insurance policy premium payment, same equal amount, equal intervals of time, you are paying for some period. Similarly, your EMIs on your loan, they all fall under the category of PMT, which is more like a recurring payment of the same amount at same intervals of time. The interval also should be the same. In that case, I'll treat it as PMT, whether it is a payment or a receipt. So in all these cases, wherever the amount, whether it is PV or FV or PMT, it could be a payment or it could be a receipt also, but it should be at periodic intervals of time. Now the good thing is, if every question we look at least the first 3-4 questions in that list, they will contain 4 of this in the question. The 5th one we have to find out. Almost all Q1, Q2, all the 4 questions, they'll contain 4 of them. Only the 5th one is what we have to find out. And the good thing is, these 5 are formulas themselves. They are fields, they are values, and they are formulas also. So let's say if I want to find out the FV, the remaining 4 will become the input for it. If I want PMT, the remaining 4 will become the input for it. So these 5 formulas take the remaining 4 values as their input. So these are 5 key formulas of Excel, especially targeted towards the basic investment finance. Basic investment decisions we can very well take using these 5. Let's look at. Let me take question by question. I'll take the first question. I deposit 10,000 now for 5 years, 8.5% per annum. How much will I get after that? So what are the numbers I have? I am depositing 10,000 now, today, which is it's a present value. If it is going away from my pocket, I'll take it as negative. If it is coming to me, I'll take it as positive. If it is a payment, I'll take it as negative. Any receipt, I'll take it as positive for consistency purpose. So because it's a payment today, I'll take it as minus 10,000. Right? So the PV, let me just note it as minus 10,000. What else? For 5 years. So NPER is 5 years. So the moment I say years, remember these 3 things should be in the same period. If this is years, this should be yearly rate. And if at all there is a recurring payment, it should be an yearly recurring. It should not be a monthly payment. It should be an yearly payment. So these 3 should be in the same period if they are existing. Right? Okay, so because here I have noted it as years, the interest rate also should be in years for me. The interest rate is 8.5% per annum. So I'll take this as 8.5%. Now, the PMT is 0. There is no recurring payment. I am doing one lump sum deposit and I want something after 5 years. So the PMT I can take it as 0 here. So all 4 values are available. Only the 5th one I have to find. It's like recurring payments. Recurring payment. I am representing it as a PV. Today's deposit or today's receipt. In this question, I am depositing 10,000 today. So it's like some cash going off my pocket today for something coming in future. So that is what I represent. It's only for a representation purpose. I am representing it as a today's amount. Because if I deposit something, I have to get something more in future. So I'm trying to, if I deposit 10,000 every month or every year for 5 years, how much will it become at the end of 5 years? Then I will use 10,000 as the PMT. Because 10,000 I am depositing not once, but every year. So then it becomes a PMT, which is like a recurring payment of the same amount at equal intervals of time every year. Then I will have a PMT, otherwise it will be 0 itself. Probably will add that question also. Then I can say equal to FV. If you see, the remaining 4 will be my inputs. The rate, I'll point to this. The NPER, I'll point to this. PMT, I'll point to this. PV, I'll point to this. Type and all we can ignore, because they are more talking of is the payment made at the beginning of the period or at the end of the period, which is applicable more for annuity payment, which is more like a regular recurring payment kind of stuff. But for one lump sum, that is not applicable at all. So it says after 5 years, you will get 15,036.57 if you deposit 10,000 today, with the interest rate being 8.5% per year. Now I can play around. Okay, now if the interest rate goes to 9%, I will get 15,386. That's how I can keep changing the scenario. Right? Now, okay, let me take the next question. Question 2, where I have simply said if the compounding is done quarterly, which means the interest rate should become a quarterly rate, the period should become quarters. That's the only difference, right? So this amount will not change, so I'll take exactly this number itself. This will become by 4 because I want it as a quarterly rate. Annual rate is 9%. So quarterly rate is 2.25%. Quarterly rate is 2.25%. Similarly, NPER, they are 5 years. Number of quarters is 20. Per year there are 4 quarters. So number of quarters will be 5 into 4. Which will be 20 years. Then of course the PMT anyhow is not there. But if it is there, it should be now talking about quarterly repeating interest. The payment should be made quarterly. Right? Now I can try computing FV. This time again the calculation is for FV only. This is the rate now. The NPER is this much. The PMT is this much and PV is this much, which will work out to 15,605. So slightly more amount I am getting, because if the compounding is happening at a more frequent basis, I will get more amount, right? Because the interest is applied on the interest very early in the period itself. So almost 200 odd or 200 odd I am getting because of quarterly compounding itself, because the compounding frequency is changed. So if it becomes monthly or if it becomes even more daily, then probably we may get even more slightly extra amount. So this is a very common investment scenario. I deposit something, how much will I get in future? Then we will look at, let's say, the fourth question, the EMI part I will come in. If my money is doubled in 10 years, right? Sometimes this is a very common advertising pattern, right? Double your money in 6 years, 7 years. All the government schemes, they promote more in that way itself. Earlier they used to promote all these Indira Vikas Patra, Kisan Vikas Patras. They used to promote more like double your money in this much of period. Today also I keep hearing some of these kind of ads. So in that case, I want to find out what is the typical interest rate they are giving. Because the world of finance, there is nothing called simple interest. Especially when it comes to my investing, everything is bothered on compound interest basis itself. So all these formulas, they simply solve out or do calculations on the basis of compound interest basis. Because almost any investment, I won't look at it as a 1 year return. For this period, what is my average return which I have got, which will come out as a compounded annual return itself. So that's where everything goes under the concept of compound interest. So that's where if my money is double, let's say, otherwise if I go with a simple interest basis, if I say my money is doubled in 10 years, you may say probably it's a 10% interest. If I go on a simple interest basis, 10% interest, then in 10 years your money is getting doubled. So I may get into a feeling that I am getting 10% return in this investment. But in reality, I am not getting that much. So how do I test it out? Probably if my money is doubled, so I deposit 1000 now, I'll get 2000 after some period. Any number, right? It hardly matters. Number does not matter here. I say I deposit 1 rupee now, I'll get 2 rupees after that 10 years. I can take like that also. So I deposit 1 rupee now or 1000 rupees now. I will get 2000 after 10 years. So the interest rate is what I have to find out. This is a 10-year period and no PMT, no recurring payment. So all I need to find out is the rate in this case, which will again come out as the number of periods will come out to this much. PMT will be this, PV will be this, FV will be this. Around 7% only. If someone says that your money is doubled in 10 years, in literal sense, it is giving you only 7% return. If I just put even 2 decimals, it is coming out as 7.18% return. That is the interest rate. So probably you may say if the regular bank deposits itself are giving me more than this, so I will not go with this plan. For this, you should do this calculation itself, because otherwise you may get, if you do it as an approximate, you are saying 10% there, whereas it is coming only at 7%. 3% is a big difference that is coming. And that too, if the period increases even more, the difference will be even more significant. So that's where this rate calculation. So these are the 5 fields at the end of the day. But these are the 5 formulas also. So at any point in time, 4 will be available. For any kind of investment scenario, 4 will be available. I need to work out on the 5th one. Right? So these formulas are straightforward for me to take my decisions. And the next thing, the third part, if I borrow 20 lakhs at 11% per annum for 20 years, what is my EMI? $20 lakhs I am borrowing, which means I am getting 20 lakhs today plus 20 lakhs. Because I am getting them 20 today, I'll write them as 20 lakhs. At the end of 20 years, there is a zero payment. As a part of the loan, I'll clear everything within this 20 years as a regular monthly payment or whatever. At the end of 20 years, there is no loan that is left. So my future value is 0. The rate, okay, it's 11% per annum, but we are doing a payment monthly. So this has to be converted into monthly rate, monthly interest rate. So 11% by 12, right? But I'll keep it as 11 here itself. In the formula, I'll make it by 12, right? Because computing it and finding out the approximate number would be, it's not perfectly divisible, no? So it becomes rounding off and all those issues will come. So I'll keep it as 11 itself, and in the formula I'll handle that divided by 12. The years also 20 years, but I have to convert them into months because the payment is asked about what is the EMI, not EYI. If I say yearly installment, then probably I can retain them as it is. But because I need EMI, the payment is monthly and all three should be in the same period. So I have to convert the remaining two into the months itself, right? So I'll use a PMT formula because I want that recurring payment now. I want to calculate how much would be the recurring payment. That is where I use the PMT formula. The rate, I can take, this is the annual rate. I'll divide by 12. This will become the monthly rate. Similarly, periods, these are years. Multiply by 12, I'll get in months, right? Because we are the question is talking of what is EMI. So even the other two, the three yellow colored ones should be having the same period. So I have converted even the rate into yearly rate and even the number of periods into number of months, right? Then after that, the PV is the loan which I have taken. The FV is how much will I pay in lump sum after 20 years. There is nothing. So here it is saying your EMI amount is 20,643. You have to pay 20,643.77 every year to pay off your 20 lakhs loan for 20-year period. Now if your loan amount is only for 15 years, your EMI will become 22,000. Like that you can work around. If your EMI is only for 10 years, your EMI will become 27,550. That's how you can work around. By just changing one number, you can work around on your calculations. That's one aspect. Now, on this, I would like to know what is the breakup of my principal as well as interest. For each month, what is the breakup of principal as well as interest? Because again, from tax perspective, they are treated differently. Or from various perspectives, there is a difference between the treatment to the principal as well as interest. So I really need to, or if I want to pay back the principal after a certain period, I need to know how much I have to pay to clear off the loan. So from various perspectives, I need to understand the breakup of this EMI into principal and interest, right? So let's say because this is a 10-year loan, I would like to find out month-wise what is the breakup of, so I'll take 1 to 120 months. One to 120 months, the breakup of principal and interest, right? And probably total them, then every month it should be equal to the EMI. If I add up the principal component and interest component, if I add them up, it should be equal to my EMI. So I will very well say, okay, For finding out the principal component of the loan for that particular period, I use a formula called PPMT, the principal part of the PMT. Principal part of the PMT is PPMT and interest part of PMT is IPMT. I can use these two formulas. Okay, the principal component as well as interest component. So I can use a formula called PPMT and IPMT. It's more similar to your PMT. The only difference is they will bring in NPER as well as PER. There is only one extra field that is coming in, which is PER along with NPER. PER is the current period. First month, second month, third month. Because for each month the principal is different, interest is different. So which month I am interested in is what is the PER. But NPER is the total, 120 months or whatever it is. So the PPMT, I'll try to put it rate. This is the number divided by 12. Better to put a dollar because I'll drag it now. For all the months I have to do. So I'll put E dollar 12, E dollar 4 divided by 12 because I'll drag it down now. Then it should not be impacted. The period will be this one. For the first month, what is the principal? For the first month, what is the interest? That is what is the period. So if I drag it, it will become 2, 3, 4, 5 like that. Then similarly, NPER is the number of periods. This number multiplied by 12 because I want it in a monthly form. Again here also I will put the dollar. Similarly PV, this is the number. Again I will put dollar. And FV, this is the number. Here also I will put dollar for the dragging. F4. The current period, which is for the first month, I need breakup between principal and interest. For the first month, second month, third month, because each month there is a difference in the principal and the interest. Though the EMI is the same, the breakup between the principal and the interest are different. So it is asking for which month you want that breakup. FE is this one only, 0. PER is the period for which you want the principal. I mean, the breakup, let's say 4th month. What is the breakup between principal and interest? NPER is the total number of loan period, 10 years. PER is, see, every year your principal and interest will change, no? So for which year you want to find out, or for which month you want to find out the breakup between the principal and interest. So then I can simply drag it down. So it is, you are seeing now the principal component, it's keeping on increasing, right? Because every month along with the interest you are paying something more. That something more is actually going towards the payment of the principal. So your principal is getting reduced and reduced and reduced. So as the time is progressing, your interest is coming down. So out of whatever the lump sum you are paying, major contribution is going towards your principal itself. Similarly, I can use IPMT, which is the interest portion of the payment. Same logic. The interest portion of the EMI, I can use IPMT. Again, the rate remains the same, divided by 12. Exactly the same way we have done the PPMT. The period will be this one. The NPER, this multiplied by 12. then PV, the same things which we have applied in the PPMT formula, and FV. Right? Now this gives me the interest component is 18,333. The principal component on this loan is 9,260 for the first month. The interest component is this much. Now as we proceed further, the interest part is going down and down, the principal part is going up and up, because you are paying some portion of the principal, the interest part keeps coming down. Now if you just try to add up these two things, it should match with your EMI every month. 27,550. This is matching with your EMI, and even every year we see that the principal plus interest combination is matching up with your EMI. So this typically like your amortization schedule. So you can very well plan out the contribution to the principal and the interest in each of the periods, right? Because again, the treatment with respect to tax and all would be different as on principal as well as interest. So you need, let's say in the first year, if I want to see what is the breakup for the first 12 months, so my principal part is 1,16,000 something, whereas the interest part is around 2,14,000 in the first year. Like that, every year I can very well plan out what is the contribution of the total EMI into the principal as well as the interest. Then it's a dollar problem. Just put appropriate dollars, you'll get it. Sorry? Just check it out. Somewhere you might not have put the dollar. Alright. So a couple of more questions. Let's say something like this. If I have invested 10,000 today and I am getting not a constant amount, different amounts every year. Like some of the plans, especially some insurance plans talk about it, some money back or something they come out with the schemes, right? So you deposit something now, let's say 3,000 you can withdraw after first year, 5,000 you can withdraw after second year, something like this. Let's say they are giving a scheme. So where the amount is not uniform, I am depositing one time and I am getting different amounts at different periods of time. This is what is the way I am getting different amounts in different periods of time. If this is the scenario, I want to find out what is the overall return in this entire process. This kind of a return is nothing but my internal rate of return, which is IRR. I invest something, different amounts I get at different periods in time. I want to find out the kind of return during this entire process, the average annual return during the entire process. I am calling it as an IRR. So I can simply use a formula of IRR equal to IRR, where I just need to enter these values. Just give these input values, which will tell me this is the return I am getting in this process. So just formatting it for 2 decimals. So if at all an any investment says you deposit 10,000 today and we'll give you the pattern in this mode, payments are made in this mode, it means you are getting a return of 21.09% in this process. See, okay, at the end of the year if I assume, but if the time frames are given, so probably if I say, okay, I'll add some more time frames. You deposit today, 26th August 2012, And if I say, okay, 31st December 2013, you will get 3000. Right? I'll give irregular time frames. Right? Or 9th September 2014, you will get this. Right? And probably 25th November 2015, you will get this. And probably 20th August 2017, you will get this. Let's say the time periods are completely different. Then a normal IRR cannot work. If they are all uniform time periods, then an IRR can work. But if they are completely different time periods where there is no uniformity, where the dates are completely different, the better formula to use instead of IRR is XIRR. XIRR is more like an extended IRR, where dates are also taken as an input into the process. So I can say XIRR, where along with the values, I also take the dates. I can take anything first or in that order, values first and then dates. Yeah, they have given no? The values and the dates. So in the values column, I'll take the values. In the dates column, I'll take the dates. That's it. Now the rate will change. Now the rate has become 18.25%. See, so if there is a uniformity that 1 year from now I will get this much, 1 year, 2 years from now I will get this much, then I can use a simple IRR. So what will be the difference between IRR and XIRR? See the date, the time value of money. No. This XIRR, we are using it for a time frame which is not at regular interval. Correct. IRR we have to use only for a regular interval. Correct. For which the future value will be actually 0. For we? For IRR function, future value is 0. What will be the end value? No, not future. Future value is not 0. See, in future only you are getting this much amount after 1 year, this much amount after 2 years. I am trying to find out at what interest rate the entire investment, let's say the present value of all these future cash flows is equal to the present value of my investment. It's like a break-even point. At what interest rate my investment cash outflow is equal to my cash inflow. Right? In a technical sense, it actually calculates like the present value of each of them. Let's say 3000 is going to come after 1 year. So the present value of that will become 3000 by 1 plus r at some discounting rate. Then similarly 5000 by 1 plus r squared. Like that it goes. So this the entire thing should be equal to 10,000. So at what are the inflows? These are my inflows. This is my outflow. Where my outflows are equal to my inflows is becoming my IRR. Now if the duration is different, now this 1 plus r is actually an year. Now if it is only 11 months or something, this should become to the power 11 by 12. Then this is, if this is after 2.5 years, this should become to the power 2.5. So because of this, the R value will change. Because the discounting factor is happening at different time periods of time. Right? In IRR function, basically assume that it is happening at annual basis. At the end of the period. If it is quarter or month or whatever it is, then you will get it as a monthly return. If I say these 4, then this 21% is a monthly return. You do it multiply by 12, you will get yearly return. Which one? No, simple. In IRR, you just give this as the input. Yeah, 10,000 is also a part of it. All your output as well as input. Even in XIRR, the same. Output as well as input, and even the dates. Right? Then the same thing, let's say in this, if I say, okay, my objective is to get 12% return. My objective is to get a 12% return every year. Then is this a profitable investment or not? Obviously, I can compare that this investment is giving me 18%, but my objective is only 12%, so I can very well go ahead with this investment. Or the other field that can help me in this process is XNPV. NPV, which will tell me what is the net present value of my investment. So if the net present value is positive, I say this is a profitable stuff, which you can do it even from here also. If I have computed the IRR, I don't require NPV separately, because IRR compared with my objective, it will become a good investment. IRR is more than my expectation, it's a good investment for me. So if my expectation, let's say, goes to 19%, then probably this is not a good investment. So the same thing will be given by my NPV also. The moment I say XNPV, because here the time periods of payment are different, I will talk about XNPV here. Okay, XNPV. I'll give what is the rate. Rate I am saying 12%. Here my objective is 12%. The values are this, and the dates are this. So this is giving me, there is a positive value, 1,500, which means if I look at the today's value of both cash inflows versus cash outflows, my inflows are 1,500 rupees more than the outflows. So my inflows are 1,500 more than the outflows, which is like a profitable thing for me. But if my objective is 20% return, but if my objective goes to 20%, the XNPV becomes minus 382, because the investment is giving a return of 18.25%, but I require around 20%. So my outflow is more than the present value of the inflows by almost 382 rupees. Again the same. NPV assumes that the payments are done exactly at the end of the one period. If there is a timing difference, today none of the payments happen exactly at the end of, if we are talking about a big project financing kind of world, all projects there are irregular payments or irregular time period payments. That's the case today. The XNPV and XIRR are more powerful. The 2003 version of Excel did not have these two formulas. So because of the growing demand for computing the NPV on a dynamic basis, NPV and IRRs on a irregular period basis, they came up with this XNPV and XIRR kind of formulas. But the underlying concept is one and the same in both. The only stuff is the time periods are not uniform, so I cannot use a simpler formula. I need to even take what the system does is based on the dates which we have provided. It will see how many days to maturity is still there. Based on that, the discounting factor is applied accordingly. So the present value will change in all these cases. Right? Correct. Should be accepted or not? Correct. I mean, if I look at the value of all the benefits as on today's date, my benefits are 382 less than my investment. It's not good worth for me, right? If I do it as 18.25 only, it's almost, because there must be some kind of rounding off here. So it is saying 0. The NPV is almost 0, which means the present value of all my future investments is exactly same as my outflow. Inflow is same as my outflow. It's more like kind of break even. If my inflow is more than my outflow, it's worth investing in those kind of assignments.